block diagram is a diagrammatic representation of a system, and the different blocks represents the various components that form a system. And by means of a block diagram, you can see the cause and effect relationship, that is the relationship between the various components of the system.
We are now looking at the terminology which you might come across during the course of this video. First one you see is the closed loop system. In a closed loop system, the output is given back as a reference for the input, and the system makes the output as close as possible to this reference. That is the closed loop system. Whereas an open loop system, the feedback is, that is the output is not fed back to the system. That's the difference between the open loop and the closed loop system. Then we have the forward path. That's something you'll come across during the course of this video. Forward path is, as you see here, it's given here that it's the transmission path from the actuating signal E of S to the output C of S. Now, putting it in easier terms, forward path starts from the beginning, that is where the input is given, that is E of S in this case, to the output, and without crossing a particular node more than once. That's a forward path. It goes from node to node, from the input to the output, and it does not touch any node more than once. That's called the forward path.
And the next one is the summing point. So the description of a summing point is given there. So a summing point is a circle which has a cross in it, and it could either have the plus or the minus sign in it, and it basically denotes the summing operation. So if you have plus, it indicates the signal is being added, and if it has a minus sign, it means that the signal is being subtracted. That's the summing point. Then you have a branch point. Now a branch point is a point from which there are two or more signals going concurrently to other blocks to summing point. So if you have a point which is called a branch point, you'll have a minimum of two signals going out from it, two or more signals. So that's the branch point. Besides this, other terminologies you'll have to know the block. What is a block? A block is an element which is a part of it. An element of the system is called a block. It usually denotes an operation which is being performed in the input signal to give an output signal. So a block is an element of a system. It is usually an operation which has to be performed on the input signal to give the output signal. That's a block. Besides this, there's nothing else you need to cover for this video at least. We are now going to look at the block diagram reduction rules. Our first rule is cascading of two blocks. We have blocks G1 and G2 of S here. So when you have two blocks with arrows coming out of them, or the signals from them going in the same direction, then those two blocks can be cascaded or combined into a single block. Here we have G1 of S and we have G2 of S. So those two blocks, after being cascaded, form a single block which contains G1, G2. So basically in cascading operation, we are multiplying, or we are taking the product of the two blocks and putting it into a single block. So we have G1 of S, we have G2 of S. After cascading, they are put together into a single block which is known as G1, G2, or it could also be known as G2, G1. Then we are going to a second point, which is the moving of a summing point. Here we are moving the summing point behind a block. When we are moving the summing point behind the block, the branch leading to the summing point will get a new block which is the same as the block behind which you are moving the summing point. So when you are moving a summing point behind a block, the branch leading to the summing point will get a block which is the same as the block behind which you are moving the summing point. Here you have G, and you have the summing point being moved behind the block G. So we're getting a branch, we're seeing that the branch gets a new block which is the same as G, that is it also contains G. The same way we have moving a branch point ahead of a block. When we're moving a branch point ahead of a block, we find that the branch will get a new block which is the same as the block ahead of which you're moving the branch point. So when you're moving a branch point ahead of a block, the branch from the branch point will get a new block which is the same as the block ahead of which you're moving the branch point. This is the third rule. Now we're looking at the fourth point, which is moving a branch point behind a block. When you're moving a branch point behind a block, the branch from the branch point will get a block which is reciprocal of the block behind which you're moving the branch point. So when you're moving a branch point behind the block, the branch from the branch point will get a new block which is the reciprocal of the block behind which you're moving the branch point. Then we have moving a summing point ahead of a block. When we are moving a summing point ahead of a block, the branch leading to the summing point will get a new block which is a reciprocal of the block ahead of which you are moving the summing point. This is a fifth rule. Now we are looking at a sixth rule, which is elimination of a feedback loop. Now as you can see from the summing point, you have an arrow going one direction to the block. That is the signal going to one block, and from that block you have another signal going it's continuing in the same direction. Now you see a branch point from which a signal is going in an opposite direction to the previous signal. In that case, it forms a loop. So this loop can be eliminated, which is called as elimination of a feedback loop. You can see the formulas over there. If the summing point has a plus, then you will have G by 1 plus GH. Whereas if the summing point has a minus, you will have G by 1 minus GH. This is the sixth point. Besides this, you also have another rule which is called paralleling of two blocks. Now in paralleling of two blocks, if you have two blocks in parallel branches and both the branches are going the same direction, that is the arrows are pointing the same direction, then those two blocks can be parallel. So in parallel operation, you're going to add the two blocks together to form a single block, and the branch both the branches get combined into one branch, and both the blocks get combined into one block. So when two branches are there which are parallel to each other, then those two branches can be, or the blocks in those branches can be parallel, and after conducting the parallel operation, you will have one single block which is the sum of the two blocks. Now another important point I need to mention, this is a mistake most students make. They think a branch point and a summing point can be moved this way or that way. See, a summing point can be moved ahead of a block or behind a block. Similarly, a branch point can be moved ahead of a block or behind a block. But a summing point cannot be moved ahead of a branch point or behind a branch point. Same way, a branch point cannot be moved ahead of a summing point or behind a summing point. So never make that mistake. That's a mistake some students quite commonly make. Let's now look at the problems. We'll try doing some problems. So here we have a first problem. You can see the block diagram over here. So before we look at the solution, let's just contemplate about how to proceed with the problem. Just look at the problem. Before you start with the problems, I would request you to take out a sheet of paper and work out as we go. It will be more helpful and you'll probably understand better if you do that. Now we're looking at the problem. So what is the first thing we can do? You can see that the branch point between G3 and G4, that branch point could probably be shifted behind G4. That way G3 and G4 will be ready for cascading. They can be cascaded. That's one thing you can do. So what can we do after that? You can see that once they cascaded, you'll have a loop, a feedback loop. G3, G4 in one block and H1 together, they'll form a loop. So we can use the eliminating the feedback rule, and we can eliminate that. So with that, we'll be losing the branch point. Now we'll have, after elimination, we'll have a value there, and we have G2, which can be cascaded together. And after that, we'll have another feedback loop, which can also be eliminated. Finally, we'll be cascading G1 and the value we're getting from all this. And the final thing which we'll be doing is eliminating the final feedback. So with this we'll be completing the entire problem. Now we'll look at the solution. You can see in the solution that they've gone ahead exactly as I mentioned. They first shifted the branch point between G3 and G4, and then they've cascaded G3 and G4. Then they've eliminated the feedback loop, that is H1 and G3 and G4 they form a feedback loop. And after eliminating the feedback loop, they've cascaded G2 and the value which forms from that, that is G3 G4 by 1 minus G3 G4 H1. They're cascading those and then we realize we have another feedback loop. And before we look at the other feedback loop, we should realize that when we're shifting the branch point earlier, the branch point between G3 and G4, when it's being shifted, the branch which has H2 will change to H2 by G4, because we're shifting the branch point behind G4. The branch will get H2 by G4. That's what they've done in these two steps. We look now at the next step. In the last two steps we noticed that the G1 and the other block next to G1, they both cascaded, and then we're eliminating the feedback loop. Here we're having a negative feedback, so eliminating negative feedback, and we're getting a final value which is CFS by RFS, that is the output by the input. So we've done one problem. Let's now look at the next problem. We are now looking at the problem 2. As you can see, this is a little simpler than the previous one. So what's the first thing they're doing here is, first they are eliminating the feedback, that is G1 and G2 together, they have a feedback, they form a feedback loop which can be eliminated. Once they eliminate it, we find that the blocks KC and G3 can be cascaded with the block G1 by 1 plus G1 G2. So once we're cascading that, we get our next step. In the next step, they are eliminating the feedback loop, and we're getting the final answer. So YFS by XFS is equal to KC G1 G3 divided by 1 plus G1 G2 plus KC G1 G3H, which is the final answer. We are now looking at a third problem. So first let us look at the question. We notice that there are two feedback loops. The first feedback loop is formed by the blocks G1 and H1 together, and the other one is formed by the blocks G2 and H2 together. So eliminating feedback, we're getting the blocks to be G1 by 1 plus G1 H1 and the other block to be G2 by 1 plus G2 H2. Because they have a negative sign in the summing point, we're getting it to be 1 plus G1 H1 and 1 plus G2 H2. If it had been a positive, it had been a plus in the summing point, that is, if it had been elimination of positive feedback, then we would have got it to be G1 by 1 minus G1 H1 and G2 by 1 minus G2 H2. But here we're having negative, that is elimination of negative feedback, which is why we're getting this. Now we notice those two blocks can be cascaded. So after cascading, we're getting a single block. Then we now notice that it's actually forming a feedback loop. So we can again eliminate the feedback loop. It's again elimination of negative feedback. So after eliminating, we're getting CFS by RFS to be G1 G2 divided by 1 plus G1 H1 into 1 plus G2 H2 plus G1 G2 H3. So we got enough final value. So this is the transfer function. All this while we notice CFS by RFS to be the final value. So what exactly is that? It's the transfer function. So what is the transfer function? It is the ratio of the Laplace transform of the output to the Laplace transform of the input, taking 0 initial condition. That is the transfer function. So this is a block diagram reduction. Completely we've done it. We've done 3 problems. I hope you understood, and we'll be ending with this.